This is table 5.2a, growth of $100 with 10% compound interest, with the demonstration of how periodic interest is applied through the compounding process. Let's see that in Excel. So we first denote time 0 plus 1, and we go through 5 periods. So 1, 2, 3, 4, 5. At period 0, the value is $100. And everything else, let's just mark it as nothing. And there is a compound interest formula, so FV equals PV times 1 plus R, the rate, to the power of T. That's the formula we're going to use. And here FV is the future value, PV is the present value, that is the starting point, R is a rate of interest, and T is a time. How many periods it has traveled across. And we can use the Excel FV function, and this will be a good demonstration of that. So first we will start with $100 at the beginning of period 1. The amount that we'll get is equal to PV. Oh, we didn't put the interest rate, 10%. So H1 has the interest rate. So interest rate equals that times parenthesis 1 plus $H$1 to the power of, well, if it's the previous period, just that. But if we want to start with the first period, then we have to assign a power. So in this case, it's going to be power 1 to the power of 1. So we'll just leave it at that, 110. And the interest is calculated as a difference of these two values. Now the formula is this, but we'll use the FV functions equal FV. The rate is $H$1, and we are fixing it because we might copy it down. The number of periods is 1. The payment, there's no intermediate payments. The starting value is $I, $4. That's the important part, and the type is 0. We'll get the same amount. And had we made this $I, $4 negative, that means paid the money today, we would have received the higher money tomorrow. So it's positive. So that's the way the FV function operates. Okay, after the end of the first period, the amount so obtained becomes a principal at the beginning of the second period. So the compound interest formula is working. And all I'm doing now is Control D, because it's calculating correctly everything from the formula we entered. This is the formula, so we don't need to copy that down again. And all I'm going to do now is use Control D, because we've fixed the rate and the starting values, but we've not fixed the number of periods. So it's moving down, the number of periods is moving down as we progress in time. The interesting matter is we can get the 121 from 110, but as you saw in the formula, we can get the 121 also from 100 as a beginning value using 2 periods. And that kind of triggers off a chain reaction, which is seen in this table here. So you can get the 121 from the 110 or from the 100. The next one is even more interesting. Now we have 121 is a starting value. 133.1 is the ending value. All I did was Control D. And again, Control D will give us the interest. And Control D will help us find the 133.1 using the FV, or the future value function. The interesting part is, now this is the aside, we can get the 133.1 from 121 as we got here. We can get the 133.1 from the 110. So times parenthesis 1.1 to the power of 2. And how do we get the 2? Well, it's basically the difference of this and this, 133.1. We can get the 133.1 from 100. So equals this times parenthesis 1.1 to the power of this minus this, 133.1. So we got it from 100 we got it from 110, and we got it from 121. And that's exactly what's being illustrated in this figure. Moving on to the next step, 133.1 becomes the starting value at this period. 146.41 becomes the ending value. Difference of these two, about 13.31, is the interest. It's 10% of 133.1. But the interesting part is it can also be obtained from 100 as a starting value using 4 periods with the 10% interest. And so we can also obtain it from 121. So all I'm going to do is Control D. Let's try Control D. Yep. I used 121 as a starting value. I used 110 as a starting value. And now I can use 100 as a starting value as well, using the same principle. So times 1.1 to the power of 4 minus 0. We'll get 146.41. Let's do it one last time for the illustration purposes. So this becomes the starting value. The ending value is 161.05. The interest is 14.641. It's 10% of this. And we can find out using the FV function with $100 as the starting value. Same answer. We can also use 133, but for 2 periods. We can use 121 for 3 periods. We can use 110 for 4 periods. And we can use 100 again for 5 periods, like we did in the FV function, times 1.1 to the power of this minus 0. 161.051. And that's exactly how this table is constructed. We generalized it by saying the value at any point of time t is 100 times 1.1 to the power t. Or simply put, we can use the FV function in Excel. That's table 5.2a. Thank you for listening.